Other exponents to review before we proceed. Any base to the exponent 0 equals 1. A to the 0 equals 1. Why? Because anything divided by itself, so 2 to the 5th divided by 2 to the 5th equals 1. And after we do all of our canceling, we're left with 1. But we also know from our quotient rule to subtract exponents. So 2 to the 5th divided by 2 to the 5th is 2 to the 5 minus 5, which gives us 2 to the 0. Same thing. Therefore, 1 must be equal to 2 to the 0. So a to the 0 equals 1 for any base a. So all of the following will equal 1. 5 to the 0, 20 to the 0, negative 5 to the 0, and 1,000,000 to the 0. All equal 1. So what about negative numbers? If we have a negative as part of our base and the exponent is odd, we'll end up with the same as negative with a positive base, because two negatives will pair up to give us a positive, and then one left over will be negative. If you have a negative base and an even exponent, you will get the same answer as the positive base to the same exponent, because we have two negatives there. We'll always have pairs, and all the negatives will cancel out to give positives. Negative 2 to the 5th, our exponent is odd. When I cancel two negatives at the same time, because a negative times a negative is a positive, I'm left with a negative. Positive times negative is negative. And the last one, negative 2 to the exponent 6, even exponent, one pair of negatives to be positive, another one to be positive, another one to be positive, so our answer would be the same as if our base was positive. So product law, when multiplying identical bases, you add exponents. Quotient law, when dividing identical bases, you subtract the exponents. Power of a power, when you have a power raised to another power, you multiply exponents. Zero exponents, anything to the exponent 0 is equal to 1.